For my IDS project, I decided to tackle the issue of having hot food portable on the go when extreme kayak fishing. This includes lakes, rivers and also the sea. After the group presentations, I revisited the brief just to make sure I'd got all the points, so I began pulling it apart and highlighting some of the key elements. Following on from this, I then picked out some of the key requirements and key considerations such as desirability, strength, how intuitive it is, how convenient it is and also how safe and legal it is to use. By using the insights section in particular from the group research, I was able to look further into Land Rover and what they're about, the brand DNA and the kind of design they produce. The iconic and distinct brand is synonymous with English heritage and having a military background, which it proudly shows off in its quite defensive and rugged design. I then began to look at some Land Rover images taken from the research, such as the Defender, the Discovery and classic designs, which you can pick out some of the key brand DNA such as the contouring and the sloped fillet edges, and of course the boxy square design that's deliberately looks bottom heavy and slopes downwards. In regard to kayak fishing, I then briefly remind myself of the activity, the user, the type of environment and the task itself and what it involves. For this I used a storyboard from the first part of the project that I drew just to remind myself of a typical day for a kayak fisherman. And then briefly looked at some of the environments and limitations and some of the considerations such as corrosion, extreme weather and also laws that you have to abide if you're going to fish. Looking back at the user research trip we did, I could clarify on some of the key things we picked up on some of the insights, such as the lack of space and the fact that your hands always tend to be busy and or dirty. Similarly to Land Rover, I then pulled out some of the key kayak fishing products on the market today to try and analyse some of the features and try and analyse why aesthetically they look the way they do. In terms of the technology to power the device itself, I considered all avenues such as solar, battery and also compressed gas, before deciding on chemical energy as the safest and also most reliable source. With research and primary user testing, I was able to establish that you can actually get water to a temperature of around 60-70 degrees, which would be perfect for the type of cooking that I'll be doing. This chemical reaction consists of quicklime, or calcium oxide, or dry thermic. They're the two options, that mixes with water to produce heat energy. Although the food was nice from the user testing and nice and warm, it was rather unappetising, and also the foil package that it came in was quite fiddly and produced a lot of waste as a byproduct. Using gas was also too heavy and too dangerous in a confined space of the kayak. And the hot can is an example of technology that already exists that uses the same sort of reaction that I'm looking to get. I began doing some very early ideation, looking at how you potentially grip the products and also how the components would actually mix to create the chemical reaction. I established early on that you would probably need cutlery for this product, so I started to look at ways in which that could be incorporated into the product itself, whether it folds up or it slides into a slot. Here I was visually trying to get my head around the actual components involved in the reaction and the food and where it would go in order to get heated up properly and hopefully cooked. I then had the idea that as it was on water, and open water, it would need to be secured to the kayak somehow, so I looked at buckles, suction cups, hinges, things like that, as a method of securing it to the actual kayak itself. But then I quickly realised that actually it would be quite impractical and it would slow down the use and limit it somewhat, be fairly restrictive, and that would have to be used in one position. So I thought that as long as it's buoyant and it floats and doesn't sink if it goes overboard, you'll be able to retrieve it, as you don't really get up to many high speeds on a kayak. I then began to pick out some of the key issues that I thought might come up later in the design, such as things like the steam release, which obviously is going to be hot, the hot surfaces and the sharp surfaces from the knives, and also things like cross-contamination because you're dealing with bait and fishy surfaces. At this point I actually had the clear idea that I wanted to utilise the fact that you're actively trying to catch food and to cook it there and then within 5 minutes of actually catching it to be as fresh as possible. Therefore the main food source for it would be fish, with perhaps a pre-prepared soup or liquid that you can actually poach in, as this is a popular method of cooking fish. So I began to get this idea of having a product that opens into several compartments, which I then made a cardboard model for to test to see if it was viable. By making it modular, I could separate the actual individual components that would be used for the chemical reaction to prevent it going off when you don't want it to. So I looked at storing the heat pad in a dry compartment at the top of the lid, and also then I looked at how you'd possibly insert it into the cavity. As you can see from the model, the middle section also opens up to reveal embedded cutlery, which you can actually take out when you need them, and also a chopping surface for actually filleting and dealing with the fish. And then the bottom would contain the water around the main cavity in which your pre-prepared soup would be. The design is deliberately very blocky and angular at this point to pay homage to Land Rover, and then the idea was that I can work it down later on into more intricate detail. With the card model I could then look at more intimate things such as how the user would engage with it, how they'd hold it, what's comfortable, and I actually looked at wrist positions and thumb positions and what is comfortable to hold, which I could then go and test to see if it actually worked. There were lots of unforeseen problems, such as it being top heavy and also quite difficult to hold with the angular edges cutting into your hand, and also the knife and the other spork that's stored inside the lid was actually far too small to use. This would need to be altered to take the design any further. So again, I revised the folding elements of the cutlery to make it more compact, and then looked at more rounded surfaces which would be more comfortable to hold. I then had a slightly revised design, which you can see in the exploded diagram, which aimed to solve some of these issues highlighted. Here I looked at how the actual pouch would get into the cavity at the bottom by having like a sliding tab that would open. And I even considered a neoprene elasticated strap that the hand would slip into so that you don't actually have any weight at all in the hand, it would all be through the wrist. But I quickly dropped this idea as it didn't quite fit right with the brief. With this slightly more detailed further design, I was able to actually mash it up in Photoshop and get some graphics on there, which showed some of the initial surfacing that I pinched from Land Rovers, including the military green and some of the air vents as well. It's already a lot more detailed, and I think you can definitely see some Land Rover DNA in there, but it still needs a lot of work. I then looked at other interesting features that I did some research on, such as suction cups, which would be useful sticking to the kayak, rubber seals, hinges, thermochromatic ink or pigment that actually changes colour when something's hot, which could be a good warning safety feature, and also looks at power drills and how they have black elements to them, which are the interactive parts, the parts you're supposed to touch. This could make the experience easier and more intuitive for the user, as it's a completely new product. I then highlighted some of these existing design improvements, but I also didn't take some of them on, such as the thermochromatic ink, which I thought was too complex for this project, and also the suction cup feet, which, although provided better friction, was also more limited and it meant you couldn't move it quickly, which I think hindered the user experience. I did think the colour brakes were useful, and also the clamp locks, such as the ones you find on vices, which would hold the parts together securely. I then took some of these features and began sketching them fairly loosely, just to see how they'd fit in with my product. This included the hinge element, which I thought was integral to the design, so the user can freely switch between the different compartments really easily. I then looked in more detail at the actual features I'd need for each compartment, things like the drip catcher in the middle section, the chopping board, and also all the buckles and clips that I'd need to hold all the pieces together as and when desired. So this meant further research and sketching, just to understand, get my head around how things like the clamps work, and also more existing research such as handles, hinges, and folding elements, even though the folding legs were actually dropped at this point as well, as I thought they were too complex and restrictive. I then looked at the flick knife, which I thought was a really clever design that makes something that's quite dangerous, quite compact and safe. And similarly, the folding spork reduces the need to have a spoon and a fork as it combines them into one. And I looked at some of the classic steam vents made out of metal that make the product look a bit more industrious and robust. I felt at this point it was good to go back to the initial research and look at some of the DNA and some of the graphemes from the Land Rover, just to make sure I'm staying true to the original brand DNA. These sloping swept and loft surfaces consist of things like bonnets and air vents, and were then considered more in the next set of ideation, just to establish a few more features. Here I was still playing around with a few forms, but I was coming up with something that was looking more like the finished product, which I could then split more accurately into the middle part, the bottom and the top part. This progressed design was then reviewed again, just to check some of the features, before making a more advanced cardboard model, which was then rigorously tested, both in the workshop with peers and also on a user scenario test in a kayak, which was useful to iron out some of the creases and to resolve these at the last minute. I then took the design to 3D CAD, to SolidWorks, to actually establish a bit more in 3D space of how it works, how it fits together, and some of the tolerances I'd need to consider. I could also then look again at the features just to make sure it was actually perfect for the user, it was intuitive and made it easier to use. The exploded view and the bill of materials show the complexity of the design, which folds away nicely into a compact, watertight, secure product. I then did some more advanced further research on materials, just to home in on the exact materials that I would need for each individual part. For example, I preferred polypropylene over polyethylene due to its far superior chemical resistance, toughness, heat resistance, which is integral to the product, and the fact you can build a live hinge into it. Most of the metal is marine grade waterproof steel, obviously for the corrosion resistance again. And for the chopping board I actually found a wood cord rubber coated material, which is heat resistant. It keeps the blade sharp, prevents it from blunting, is lightweight and buoyant, and also has a plastic coating which provides grip. For the bowl I was originally considering copper, but due to the fact that it's not magnetic it would not stick to the part below the bottom cavity, and also it was a bit too expensive for the product. So I went with aluminium instead, which was a bit of a compromise with the heat properties. With this information and some of the CES EduPack software, I could then work out a really rough material cost, work out how much it costs to manufacture and how much then it would go for sale. Retailing at approximately between £80 and £120, which I think is fairly reasonable for revolutionary technology in this industry. The final consideration once I'd established materials was actually some of the colourways. So I looked at some of the colour breaks and some of the colours that best fit the product for its purpose. I did look at the bright yellows such as the Kayak, although this didn't really fit with the brand DNA of Land Rover. So I opted for much more neutral green and black, which I think, as you can see from the final design, is more suitable.